learners, welcome to Education Online program. So today we're going to be looking at a very interesting topic known as heat. So we've been hearing about heat. How can we define this heat? Since we know that it's also a form of energy, we can define heat as a form of energy that is transferred from one point to another due to the temperature differences. So why is that transfer there? It is there because if you look at matter is comprised of very tiny particles. Let's take a look at this object. We assume if this can be a brick, so for it to be concrete like this, that means that it has been made of tiny particles. So these tiny particles are right here, just around this, all over in the material. So you see that it depends on the material we are talking about. Some materials have this very closely or compact together. Some of them have them loosely bonded together. So it depends. If you're talking about the gases, they have the molecules. If you talk about other solid objects, they have got the electrons. So this transfer of heat from one point to another due to the temperature differences, you see that it is caused because of these molecules. When one molecule has got some heat, that is energy that is greater than this one surrounding it, you see that it is going to move, if it is in case of gases or the liquids. But then if it is in the solids, they just vibrate. These electrons here will keep on vibrating. So as they vibrate, they lose their energy to the nearby electrons. So you see that those electrons also lose their energy to other electrons they come into contact with. So that will make the whole energy that was just received by one electron to be distributed in the whole system. So let's write our definition here. We are saying heat is a form of energy that is transferred through a system due to temperature difference. So if you look at that, what could be the SI unit? Because we said in physics, each and every measurement has got its SI unit. So since heat is a form of energy, that means that it is measured the same way work is also measured. So you see that the SI unit of this is the joule. So if it is the joule, how can we define joule? We have it as our SI unit. Is joule. So now what is a joule? Because you cannot give the SI unit just like that if you do not know what this one actually stands for. So if we are talking of a joule, we are saying that it is a work done by a force of 1 Newton acting through a distance of 1 meter. So you see that when you apply a force of only 1 Newton to any to an object, and then you allow this force to move a distance, maybe you're pulling something with this force of 1 Newton. So if this distance between here up to there, between this point up to that point is 1 meter, that means that you have measured 1 joule. So we can say that this is a work done. Work done by a force of 1 Newton acting through a distance of 1 meter. So that is how we define joule, which is the SI unit of heat. It is not only the SI unit of heat if we talk about joule. It is also the SI unit of work, and it is the SI unit of energy. Why are we saying it comes here under heat? Because heat is one of the forms of energy. There are so very many forms. So you find all energies are measured in joule. That's why we also have it here. So what are the characteristics of heat? If you're talking about these characteristics of heat, characteristics of heat. To find the characteristics of heat, you should be knowing how heat is being generated. So if you know how it is generated, you need to know also the movement, how fast. So we see that one of the characteristics of heat is that it is generated by the movement of molecules or particles in matter or in any other body. Since we are saying that this matter is made out of tiny particles, so the movement of those particles, and then they are bombarding with other particles that is surrounding them, gives rise to the heat. Because you find even the electrons, when they try, when I try to rub this, what happens is that as I am rubbing, if not only this, you can even use your palm as an example. So if you're rubbing it, what happens? The more you continue rubbing, you find out that there is some heat generated there because of the friction in between. So you see that it is these particles. Their particles keeps on moving, and then as they bombard, they increase the temperature of that surface there. So we shall say that one of the characteristics of this heat is that they are generated by the movement. They are generated by the movement of particles in a system. When I'm talking about a system, I mean any other body. So you'll see that if these particles do not move, that means that there will be no transfer of energy. And if there is no transfer of energy from one point, from a point where the energy is like more and then where it is less, that means that there will be no heat. Because there is a difference between heat and also temperature. We shall come to that. So what is the second characteristics of heat? We can see there, we say that the faster these particles move, more heat is being generated. So you see that how can heat move from this point to this point so easily? It will move easily provided that the particles that is making up this object here are in position to move rapidly from this point up to here, because the moment you increase the energy in this point here, that means that this side does not have, but for this energy to reach this point here, it needs the particles in this object to be faster in their motion. So the faster the movement, there will be the greater there will be the generation of this heat. So we are saying here that it is caused by the fast movement of the particles. So those are some of the characteristics of heat. So now, if you're talking about heat, you look here. As we define heat, there is a term we use there. The term is known as temperature. So now, if you look at temperature and heat, they almost look alike. If you just try to check it through layman's understanding, you might think that heat is actually the temperature. So let us look at heat and temperature then, and we find out whether heat is actually temperature or temperature is heat. Let's look at that. Heat and temperature. So if we define as heat as the transfer of energy due to temperature differences, so now what is temperature? When you're home and then you feel sick, a bit sick, you're inside, what happens is that you find someone comes inside the house and tries to touch you around, maybe around the neck or the cheeks. So what are they doing? They are trying to check your temperature. Is your temperature high? Is your body actually hot? Or is your body warm? Or is your body cold? So there they are trying to find your temperature. They are not trying to find the heat on your body. So we can say temperature is the degree, is the measure of the degree of the hotness or coldness of a body. Because touching it doesn't necessarily mean that I have to check the temperature, which is supposed to be like warm. But sometimes you want to check if the thing is actually cold. So you're still at that point there checking the temperature of that body. So we can say temperature is the measure of how hot measure of the degree of hotness or coldness of a body. Now we see how the two are actually not the same, because heat, for it moves. But now look at temperature. If you're coming to check someone's body to check whether it is warm or cold, does it actually move from that point after touching? No, it doesn't actually move. So you see that these ones, they are just closely related. How are they closely related? They are closely related in such a way that they have the kinetic energy. But then which one is carrying it more? If you look at temperature, it becomes the average kinetic energy a body actually contains. But then if you're looking at the heat, for it is the total total kinetic energy actually a body is having. So you see that heat and temperature are actually almost moving are similar, even though one is the hotness and then the other one is the coldness. So if you have that, what are the differences between these two? So let's look at the differences. Between heat and temperature. So you find out that the first difference can just come from their definitions. How have we defined heat? You see that when you look at the two definitions, they're already showing you that they are the differences, the first differences between the two. Because if you look at the similarities, there is only one thing connecting the two, which is the kinetic energy of the particle. Yes, all of them are the kinetic energy, but then to what degree also matters. So you see that with the heat, it is just a form of energy, but then is temperature really a form of energy? When we say that we measure energy in joules, do we also measure temperature in joules? The SI unit of temperature is not joule. That means that temperature is not a form of energy. So if it is not a form of energy, what is it? So since we have our heat and then we have our temperature, so we are saying that heat is a form of energy. And then we are saying that temperature is not a form of energy. So what is this temperature? So the temperature, for it, it's just the degree of hotness or coldness of a body. So that is one of the differences between the two. So we have it as is the hotness or coldness of a body. So you see, from our definition we already generated our first difference. What about after doing that? Is this the only difference we shall have between heat and temperature? No, it is not the only difference, but we have so many other differences. You find out that heat can flow. That one is still from the definition. They're saying it's a form of energy that is transferred. This word transferring here means that it can flow from one point to another. So if we say that a heat can flow, heat can flow from one point, one point to another. But then can temperature really flow from one point? Because I talked of example of touching you to check whether your body is warm or cold. After touching, does it move? But then there is this situation. When you're touching, what happens is that if it is hot, you also feel the warmth in your hands. So if you feel this and then this one is hot and then you feel in your hand, does it mean that the temperature has transferred from your body to the person's hands? No, it is not the temperature that has transferred there. But in this case, it is the heat, because each body it stores heat as a thermal energy. So that movement there, it is of the heat. It is not the temperature. So we say that temperature cannot be exchanged. So you see that it does not flow. We have it here, temperature. does not flow, or you can say it is non-exchangeable. So that is another difference between the two. So we are saying that heat, it is the amount of internal energy. So if it is the internal energy, do we feel it outside? That means that a system actually stores it inside it. So if it is storing it inside, does it store it in the form of the heat? No, it stores heat inside as thermal energy. That's why we are saying that heat is the amount of energy, internal energy of a system or any other object. So this is also one of our difference here. We can have it as heat is the amount of internal thermal energy. So if heat is the amount of this internal thermal energy, so what about the temperature? What can we talk about this temperature? We say that temperature is the average kinetic energy of the molecules. We are talking about average here. Average does not mean the total. That means if you look, when they are saying it's the amount of internal thermal energy, that means that the whole energy the body contains is what is known as the heat. What of its temperature? It is just part of it. Part of that energy is what is known as the temperature, and that energy which is known as the kinetic energy. So we say that this one is the average kinetic energy of a particle. Why are we having kinetic? Why is it kinetic and not static? Because you would have said that it is the average, maybe static energy, but then we are talking about kinetic. This is because this energy has the ability to move from one point to another. So if it could not move from this one point to another, meaning that there it would be static. So kinetic is more like dynamic. It can move. It has the element of motion in it. So let's take a look at another difference there. We can extract a difference from its measurement. How do you measure heat? And how do you measure temperature? Do you use the same instruments to measure the heat and temperature, or use different? So we shall have it as this one here. Our heat is measured using a calorimeter. If you say you use this instrument for measuring heat, do you actually use also the same to measure? So we find out that we do not use the same calorimeter to measure temperature. So what is that instrument we use for measuring temperature? If you go to the hospitals, you find out that there is something, it is a bit of this size, that is fixed in your armpit. They keep it in your armpit and then they tell you to put down your hand. What is that? That is what we use for measuring the body's temperature. That means that we use a thermometer we do not use the same calorimeter. So this one gives us another difference between heat and temperature. We say that here we use temperature is measured using a thermometer. If it is measured using a thermometer, what else do we think can be the difference? It can also be the SI unit. Are the two carrying the same derived units? Heat does not carry the same derived unit as temperature. Why? You find out that here I'm saying that it is a form of energy, so it is measured. It is carrying a derived unit, which is the joules. But then the temperature, if you measured your body temperature, do they say that maybe your body temperature is 50 joules? It's not the case. But then they measure it either in degrees Celsius or it can be measured in Kelvin. So those are the two SI units of the temperature. There are so many differences you can find between heat and temperature. So now we should not confuse the two, saying that heat is actually temperature. Heat is not the temperature because of these differences. Even though we said they had their common thing, which is the kinetic energy of the particle, it doesn't still make heat temperature, because when you look at that, still the heat takes the whole kinetic energy of the body. But then this temperature here only takes part of this, only takes part of the kinetic energy. That's why we are saying it is only the average kinetic energy. So these two are actually not alike. And then you can find out that you have two bodies. Let me say you have water. We are going to, if you get 1 glass of water, let me say hot water, which is measuring up to 100 degrees Celsius. That is already, I'm talking about the temperature of the water. So get also 2 glasses of the same water and put them in different beakers. When you try to fix your thermometer in the two, because you boil the water to the same temperature, you see that the first one, so let me see, this is your beaker A, and then we have our beaker B here, B. These ones they are all containing liquid that you've boiled to the same temperature. But then what differs here is the amount of liquid the two beakers are containing. This one had only 1 glass and this one has 2 glasses. But then if you measure their temperature, they are all giving you the same temperature, which is you've boiled them to 100 degrees Celsius. So we have our temperature there, 100 degrees Celsius. But then, will the two be having the same heat? Are they going to give out the same amount of heat? No, they are not going to give out the same amount of heat. They might be having the same temperature, but the heat there isn't the same. This one will produce heat that is twice this beaker here, because here we added another one glass from the same pot and then into this. So you see the difference. Whenever you see that two bodies are giving you same temperature, it doesn't mean that they have the same amount of heat. So you should be knowing the definition of heat, know what is common between heat and temperature, and you should be knowing the difference between heat and temperature after this lesson. So with this, we come to the end of our lesson. We shall start something very interesting also in our next lesson, which is known as the heat transfer. Let's meet in the next lesson.